Hi student, this is Sivakumar. 11th standard mathematics chapter number 6 continuation of exercise 6.3 no problem number 11. If P1 and P2 are the length of the perpendiculars from the origin to the straight lines, two straight lines given, then prove that P1 square plus P2 square that is equal to A square. So two equations of straight lines given. So better to keep the constant always in the left hand side. So plus 2a comes left hand side minus 2a that is equal to 0. Let it be equation number 1. Like that, I have taken the constant a cos 2 theta to the left hand side minus a cos 2 theta that is equal to 0. That is number 2. So what is given? P1 and P2 are the length of the perpendiculars. Length of the perpendiculars from the origin to the straight lines 1 and 2 respectively. You have to prove this result. Okay. So first one, given P1 equals length of the perpendicular from the point 0 comma 0, that is the origin, to the straight line, equation number 1. Okay. We know that perpendicular distance formula, modulus of ax1 plus by1 plus c divided by root of a square plus b square. Here a equals b equals c equals and x1 comma y1 equals x1 comma y1, that is the origin point 0 comma 0. Next, a that is equal to the coefficient of x, that is secant theta. B that is equal to cosecant theta, and the constant c equals minus 2a. Secant theta, cosecant theta, minus 2a. Secant theta, cosecant theta, minus 2a. Now we have to substitute. Modulus of a, that is secant theta, into x1 equals 0, plus b that is equal to cosecant theta into y1 that is also 0, plus c that is equal to minus 2a, whole divided by root of a square plus b square. A that is secant theta and its square is secant square theta. B that is cosecant theta and its square is cosecant square theta. Now we have to simplify. Modulus of secant theta into 0 is 0. Cosecant theta into 0 is 0. Only minus 2a. Root of. We can change into that sine and cos form. You know that secant theta that is equal to 1 by cos theta. Therefore, this is 1 by cos square theta. Cosecant theta formula is 1 by sine theta. Therefore, cosecant square theta is 1 by sine square theta. Write the formula here. Since secant theta that is equal to 1 by cos theta and cosecant theta that is equal to 1 by sine theta, that is equal to modulus of minus 2a divided by root of, here LCM cos square theta into sine square theta into sine square theta. Nothing common between these two. So how to multiply these two? 1 into sine square theta is sine square theta plus cos square theta into 1 is cos square theta. That is equal to modulus of minus 2a that is equal to plus 2a whole divided by root of sine square theta plus cos square theta identity, that is 1 divided by cos square theta into sine square theta. That is equal to 2a divided by square root of 1 that is equal to 1 divided by cos square theta sine square theta, square root is cos theta into sine theta. That is equal to 2a Division becomes multiplication. The reciprocal of 1 by cos sine is cos theta into sin theta or sin theta into cos theta equals a into 2 sin theta cos theta. That can be written as a into sin 2 theta, because what form it is? 2 sin a cos a. 2 sin a cos a formula sin 2a. So 2 sin theta cos theta is sin 2 theta. So a sin 2 theta. That is the length of P1. Like that you have to find out P2. P2 is the length of the perpendicular from the point 0, 0 to the straight line 2. P2 equals length of the perpendicular from the origin, that is 0, 0 to the straight line number 2. Same formula only. So I write that a value, b value, c and x1, y1. x1, y1 obviously 0, 0, that is the origin. I have tried the values of a, b and c only. A is the coefficient of x, that is cos theta. B is the coefficient of y, that is minus sin theta, including sin, cos and minus sin. Cos theta minus sin theta. And c is the constant term. Constant is minus a cos 2 theta. Minus a cos 2 theta. You know that formula, modulus of a into x1. A, that is cos theta, into x1, that is 0, plus b into b value minus sin theta into y1, that is 0. A x1 plus b y1 plus c is the constant, minus a cos 2 theta divided by root of a square plus b square. A, that is cos theta and its square is cos square theta. B, that is minus sin theta. Minus sin theta, the whole square is sin square theta. I written directly. That is equal to modulus of 0 into anything is 0, 0 into anything is 0, and we will be getting only minus a cos 2 theta divided by root of cos square theta plus sin square theta. The identity is 1. Therefore, 0, 0 you can neglect, you can straight away write minus a cos 2 theta divided by root 1 is 1. That is equal to minus a cos 2 theta modulus value is plus a cos 2 theta. Modulus always, it is an absolute value, it cannot be negative, it is always positive. Divided by 1. Anything divided by 1 is same thing only. That is equal to a cos 2 theta. That is the value of P2. You are asked to prove that P1 square plus P2 square, that is equal to a square. So consider P1 square plus P2 square. Consider P1 square plus P2 square. P1 value here it is a sin 2 theta and its square. A sin 2 theta and its square plus P2 square. P2 here it is a cos 2 theta and its square equals a sin 2 theta square is a squared sin square 2 theta. A cos 2 theta whole square is a squared cos square 2 theta. That is equal to, between these two you can take a squared as common, a square into sin square 2 theta plus cos square 2 theta. That is equal to a square. We know that the sin square theta plus cos square theta, both the angles are same whose value is 1. Since sin square theta plus cos square theta, that is equal to 1. Therefore, a square into 1, that is equal to a square. So we have proved the result, P1 square plus P2 square, that is equal to a square. Look at that. So it has been proved. So problem number 11 is completed. Then I will be teaching problem number 12 in the next video. Thank you, children.